Welcome to Data Platform Geeks webinar. Once again, we have a Redmond expert with us, Pedro Lopes this time, Senior Program Manager from Microsoft US. My name is Amit Bansal. I'm going to be helped by Satya Ramesh to host this webinar for you. And as promised, I'm skipping the introduction and will straight away get to Pedro's content.
This is a repeat of a session I delivered last week at SQL Intersection, so apologies for not changing the template. The topic, as you've read in the invite, is about the work that we've been doing in the last year and a half about what we've been pouring into SQL Server to help customers be more self-sufficient and more efficient in troubleshooting query performance. So in a nutshell, my name is Pedro Lopes. I'm a program manager in the SQL engineering team. You have my contacts on the screen there, Twitter and email. Please use them and ask any question after the fact. I'll not be so entertaining of questions during the session because obviously we're very late, and again, my deepest apologies for that. But I will certainly reserve some time after the fact. I can stay and answer questions, and obviously in email or Twitter. Okay, so let's take it away. The overview of the session today will be, first we'll take a look at the history of SQL Server query performance and what we have done over the years to take us where we are now in terms of SQL Server query performance. So think of this as a journey through time for those that have worked with SQL Server for some time now, and to really get a retrospect of how far have we come over the years. What did DBAs and developers live with when working with SQL Server several versions ago, and what we have now, and that we've evolved over the years to get to a point where we try to be efficient and as much time effective as possible. And then we're going to look at the diagnostic improvements that we've poured into the product. Now these span, for the most part, every in-market version that we have now. So mostly will be SQL 2016 and 17, some 2019, and some will apply also to 2014 or even 2012, but those will be exceptions here. Now, time permitting, I'll have a bonus here, a bonus improvement that we've done, but that's in case you don't get it, I'll still make the deck available, and you can see it from there. So let's start with the brief history of SQL Server performance, and that takes us back to all the way to SQL 2000, and in these three main areas that I want to focus on: the query optimizer, being the central piece of the relational engine, the piece of code that takes our transact SQL statements and optimizes it to run on the instance that we are trying to retrieve data or to change data, and does so coming up with a number of with metadata and information about the system and the underlying schema and some rules and heuristics in order to create an optimized query plan. Then we also have another area, which is diagnostics and tools, how far we've come in this area for the purpose that I mentioned a minute ago of making everything more efficient, and also query execution, which is part of relational engine, but it's actually the component that takes the output of the query optimizer and actually drives the query to completion. So starting with back in SQL Server 2000, I can't really do a show of hands here, but it would be interesting to know how many people still worked with SQL Server 2000. If you worked with SQL Server back then, you would understand, for example, the tool space was very limited. We had SQL Server Profiler. We had separately Enterprise Manager, which allowed DBAs to manage SQL Server instance, and Query Analyzer on the side, which allowed us some rudimentary query performance troubleshooting by looking at the execution plan. And we had, and we still have, the trusted SP3 store procedure that allowed us to see some information about in-flight requests in the system, and therefore understand what was happening at that moment. Now, this is still very rudimentary at this point in time. Another thing I want to call out is SQL Server 2000 introduced or was using the query optimizer model that we had previously introduced in SQL Server 7.0. Now this, called the CE70, this remained the query optimizer, a main cardinality estimation model, all the way up to SQL Server 2012. So it has grown over the years. It had evolved over the years. At this point, it was the second version that was being, the second SQL Server version that was being released with that cardinality estimation model. And at that point, the query optimizer could enact around 200 transformation rules over our incoming transact SQL in order to attempt to optimize it further. And another important aspect are the query optimizer fixes. So over the years, Microsoft has released a number of query optimizer fixes to address obviously cases and issues that customers have come up over the years. Now, unlike every other fix that goes into SQL Server, query optimizer fixes are off by default. So it's not like you install a cumulative update or a service pack and those fixes are on right then and there. You would need to, back then, enable a number of separate trace flags because each new query optimizer fix came with its own trace flag. And we started introducing knobs, let's say, ways to shepherd, to guide the SQL Server optimizer into certain path through trace flags. And we have also moved away from that in recent years. Now, enters a number of years have passed. We're now at SQL Server 2005. And 5 years later, what we've done in the area of query optimizer fixes is we had a plethora of trace flags. Like I said, every new query optimizer fix came with its own trace flag. And it was, frankly, getting out of hand. So what we've done to make it all simpler, both for customers and to ourselves as we developed, is to unify every single query optimizer fix under one single trace flag. And that came around in 2005 SP3 with trace flag 4199. So some of you may be familiar with this trace flag. It is something that is still today enables query optimizer fixes that are installed through CUs and service packs. Now, regarding query execution specifically, this was a defining release for this topic because it introduced DMVs and DMFs, so dynamic management views and functions. And it also introduced the first iteration of partitioning, which it was our first step into the world of very large databases and creating technologies that would make it easier to access data over large schemas. So DMVs allow a lot of insight into how the engine is operating in a number of facets, from query optimization to query execution to even looking at the plan cache and a number of other topics. And these have obviously evolved over the years and became a large ecosystem that we're going to take a quick look at. Then we'd also released that with this version, the SQL Server Management Studio. This brought together Enterprise Manager and Query Analyzer, but very importantly, and I want to call out that, it brought the notion of embedded reports. So you could from then click onto a SQL Server instance and explore visually a number of interesting information that was being returned by the DMVs and DMFs. Specifically, because we're talking about query performance, there was a separate download that didn't make it then natively in Management Studio, which were the performance dashboard reports. I don't know how many of you have used this performance dashboard reports over the years. It has had a few iterations, and this is a very useful tool to understand the status quo in terms of performance of our SQL Server instances. And we're going to talk about a little bit about that after this quick performance journey. Now, SQL Server 2008 and 2008 R2, they belong to the same major version. That's why I'm pulling them together. For the most part, in terms of query performance journey, what I would call out here is the introduction of the first version of extended events. Now, extended events in 2008 and 2008 R2 are different, are a very small subset of a journey that got somewhat reset in SQL Server 2012, where we actually started the extended event journey that we are on today. So we had a first version in 2008 and a second version, if you will, of extended events starting with SQL Server 2012. And this greatly introduced us on a path of replacing the very costly server-side tracing, because in terms of query performance troubleshooting, in case you need to collect and understand data of the workload that's ongoing, if you would run server-side tracing, or more commonly known profiler, in over a very busy system, you would make something bad even worse. So extended events are a much lighter way of getting the same kind of data at this point in time that we're talking about SQL 2008. But now in more recent versions, you can actually do a lot more with extended events that you could ever do with server-side tracing. Okay, and SQL Server 2012, in terms of query execution, a couple of things I want to call out. We redesigned the memory manager, which means that we have better memory usage, better memory tracking, so we can better understand and troubleshoot query performance if it has anything to do with misuse of memory. And because also we have redesigned how SQL Server addresses memory, we have also made query performance much more effective, starting with this version. Now, because obviously SQL Server workloads are very dependent on running in memory for its best performance. If we need to resort to I/O, then performance will drop, sometimes exponentially, and that is an obvious problem. Now, in SQL Server 2012, we introduced column store indexes, but you see there it's actually in little, it's in a small font, because the big call out is batch mode execution. And I know that Joe Sack is going to talk to you in sometime in the near future, and is going to dive deeper into batch mode execution specifically. So I won't deter a lot on that. But suffice to say that we introduced batch mode execution because for very large data sets and on obviously very large databases, running analytical workloads, the row mode execution does not scale well, which is why we introduced back then batch mode execution, and we introduced it in tandem with column store indexes. And up until SQL Server 2017, to leverage batch mode execution, you had to be using some form of column store in your query. SQL Server 2019 changes that, and you'll see how this actually unlocks a lot of potential benefits for analytical workloads that don't necessarily need to use column store. And again, Joe will talk about that. Okay, fast forward. We see that, by the way, as the versions evolve, we have less and less time between releases. And that trend continues. Now, SQL Server 2014, in terms of query performance, was a defining version because we introduced a new version, a new cardinality estimator that is a side-by-side implementation with the previous cardinality estimator that started back in SQL Server 7. Now, this is dubbed the C120, and if you look at the number matches the highest database compatibility level that exists in this given version. So C70 remained from SQL 7 all the way to SQL 2012, because SQL 7 was the version that introduced that cardinality estimator version. SQL 2014 introduces another one, C120. SQL Server 2016 introduces yet another one, that's C130. And SQL Server 2017, it's C140. And SQL Server 2019 is C150. And that is because, starting back then in this version, we started to gate every change into query optimization, specifically in the cardinality estimator. We started to gate changes behind dbcompat. And why is that? Well, think of you upgrading from an older version of SQL Server to a newer version of SQL Server. And if you keep the database compatibility level the same way as it was in your source system, let's say you're coming from 2008, and you upgrade to 2016 or 17, and you keep dbcompat 100, then what we do purposely is to make sure that your workload that runs on that database with that dbcompat is running in the same set of rules on the query optimizer perspective that you were in your source system. That means that plans are optimized the same way, which means that you have a sense of, you do get performance stability during upgrades. Now, as I said, this is a side-by-side implementation, CE120 and every CE ever since, which means that in case you need to, you performance got a handful of queries, then you can still go back to the previous model that is still available. Now, I want to call out that at this point in time, SQL Server 2014, the optimizer has over 400 transformation rules. In SQL 2019, we have around 405, if my memory serves me right. So even internally, the query optimizer has evolved a lot over the years. Now, fast forward a couple of years later, and we released SQL Server 2016. And this was 18 months after SQL Server 2014. But this was also a defining release in its own merit. Now, for example, in terms of query optimizer fixes, now we have now enabled every previous query optimizer fix by default under the latest DBCompat level. That means that when you move to a database with SQL Server 2016, and if you upgrade to the latest DBCompat, then whatever workload runs on that database will run with the latest query optimizer fixes enabled by default. Actually, let me rephrase. It's not the latest. It's the latest that existed up until the point we released given version. So up to the point we released, in this case, SQL Server 2016. Now, if we introduce subsequent query optimizer fixes, to enable them, you will still need trace flag 4199. And we have a number of fixes that came around after SQL Server 2016. Now, this model I just mentioned is the new default, meaning that when we introduced SQL Server 2017, every query optimizer fix that was in the engine up until the point we released SQL Server 2017 became on by default under DBCompat 140 because it's the latest 117. The same thing will happen in 19. When we release SQL Server 2019, we will bundle up all the query optimizer fixes and make them on by default under DBCompat 150 and so on and so forth. Now, the second point there is DBCompat protection. And that's mainly what I've been discussing in the last few minutes. Now, in terms of diagnostics and tools, a couple of things I want to call out. One has to do with diagnostic enhancements in the engine itself. And for that, we have lightweight profiling, for example, which I'm going to talk briefly today. And it's fully documented, by the way. And we're going to discuss a number of show plan improvements, meaning query plan improvements, information that you can find there to help you troubleshoot query performance. But also, we've invested in the tools that sit on top of the engine, and to the same purpose of making sure that performance troubleshooting is easier. We have live query statistics, we have the query store, and we have abilities, tools embedded into SSMS to allow you to compare plans and even to do plan analysis for you. In this case, specifically for the scenario of finding cardinality estimation issues. Now, fast forward 16 months, and we are in SQL Server 2017. 2017 introduced a new CE, as you see there, CE 140. And that's been the case even in 2019. We have CE 150. Now, in terms of query execution, SQL 2017 brought automatic tuning and adaptive query processing, but it also brought improved insights. For example, Query Store has new reports that were brought in with the latest versions of SSMS that match the timeline of SQL 2017. And in SSMS 17.2, we've introduced the performance dashboard reports embedded into SSMS, so no longer a separate download, and that's very useful for a quick troubleshooting of performance issues, and I'm going to discuss that in an upcoming slide. Now, in SQL Server 2019, we're bringing up a couple more topics that I want to call out. Intelligent query processing, that's a whole other session that Joe is going to talk about, so I'm not going to discuss that. And we've introduced a new tool to help you upgrade DBCompat while being able to identify and tackle potential performance issues that come due to regressions. And we call that the Query Tuning Assistant. And it's, again, fully documented. We've released the documentation last week, and it really allows you to upgrade your database. So we're going to discuss that also. Okay, so let's move on to diagnostic enhancements. Amit, by the way, if there are any quick questions you want to interrupt me, just go ahead, or I can answer them in the end. I'm all fine with that. So in terms of diagnostic enhancements, the first thing I want to call out is the performance dashboard. So this is a screenshot of what you get as the entry point for the Microsoft SQL Server Performance Dashboard. You see there a number of useful information. You see, for example, the system CPU use. And clearly here, I'm able to see immediately that this SQL Server specifically is CPU bound. Now, if there were any other processes running in this system, could that be other SQL servers or any other process, they would show up, as you can see here, in a different color. But in this case, I'm absolutely positive that this SQL Server process is driving most of CPU use in this specific host. So I do have an issue I would need to investigate starting from here. And how would I investigate? Well, if I'm using a lot of CPU and it's inside SQL Server, the logical next step could be to look at expensive queries by CPU. And I could click on this, and it opens a second sub-report that gives me a drill down of my most expensive queries by CPU. Remember that at this point, this is still not dependent on Query Store, which means that if you open the latest SSMS and point it to any SQL Server version, all the way back to SQL 2008, you get this view. Now, Query Store does persist performance data on queries over restarts, and this report does not. First of all, this report is a snapshot, and B, this is built on top of DMVs that get reset with every SQL Server restart. But for a host, a SQL Server that's online for some time, you do get very relevant information from here. Now, I can also see here another part, which is the current weights. So SQL Server operates under a weights and queues model, because obviously we do have, we have a potential of having hundreds of requests incoming for SQL Server, and we have a finite, a limited number of CPUs to run that workload on. So we kind of would need to have queues around and weights as every request tries to get its resources to be able to run. Now, in this case here, we have weights surfaced by category. And I can see here I had one in-flight request that was waiting on parallelism. Now I can see here a section on current activity, so you can explore current user requests, user sessions, and you have here historical information. And I want to call out that here, for example, if I'm seeing this weight, at this moment that I've entered this report, let me actually check if I have, this is a prevalent weight on my system. So I could go to this sub-report here and see if this was actually a recurring problem. So it does really allow you a lot of insight into the current state of SQL Server performance. Now, as I said, starting with 17.2, SSMS, there are no extra downloads. There's no new schema to deploy, because before you had to download the package, deploy a specific schema in MSDB. So it was sometimes a blocker for people to adopt this. So no more. It's right there in SSMS. You just point to an instance, right-click, reports, and you get to it. Okay, and then we have, by the way, the missing indexes report. We've added a scoring method. So we're actually only surfacing those indexes that are really, really, they have the potential of being really, really positive and beneficial for your workloads. So we've done away with a lot of the, let's say, visual pollution that could arise from looking at the underlying DMV here. Now, Query Store. Query Store is another defining tool that you should have enabled on your SQL servers 24/7. This is a flight recorder for your workload. At any point in time, you can come back and reactively look at how your system was doing and how your workload was behaving. You can see regressed queries, if any occurred. You can see your top resource-consuming queries in more detail than you can in resorting to DMVs and the report that we've just seen. You can even see query weight statistics tracked by database and per query, which is something that you can't see in the performance dashboard report because it's weights all up in the system. Now, specifically the top resource consuming queries report is super useful because, as you can see here, it allows you a visual exploration of your most resource consuming queries for that specific database. Now, obviously, the screenshot that you have here, it's a test that I was doing, so I only have actually one query that jumps to the eye over all others. Now, interesting that I can see here is that for this query, I can immediately see the query plan. And I can see that over time, I have a scenario where I have two plans being used iteratively over the timeline. Now, if I have this over the same timeline, this means that I can start deriving hypotheses from here immediately. For example, if I have a plan that's being recompiled all the time, I can have either A, the recompile hint in the query. Actually, I don't have it because I don't see it here. Or B, I'm actually facing a parameter sniffing issue, and therefore I may be recompiling the plan over and over again, and I do have parameters here, so that's a reasonable hypothesis to go and chase. Now, I can explore these reports and any report in Query Store with any metric I choose. The default is duration, as you see there, but I have all these others. I have execution count, CPU time, IO, DOP, and all of the other ones. So, for example, if I notice, like I did in the previous dashboard report, that my server is CPU bound, I'm actually going to Query Store in my databases looking for the top resource-consuming queries by CPU time, and then start analyzing from there, because if I am able to tackle the most resource-consuming queries in terms of CPU, if I'm able to tune them or do some other action that decreases CPU consumption, then I fix the overall issue. So these tools work well in tandem. For example, I've just started with Query Performance Dashboard to see the overall status of the server, and now I can use Query Store to drive deeper into each database's workload. Now, in SQL 2017, we included weight types or weight categories in Query Store, so that's an additional metric. And because we've added that, the latest version of SSMS, Preview 5, also introduces a new report specifically to look at the weights on the workload. So you can do now weights-based troubleshooting from the UI. For example, here for this database, I'm seeing that the workload is mostly waiting on memory. This can be either this is typically waiting to acquire memory in order to start executing queries, and that is by far the most wasted time that I have in the workload that runs in this database. Second is CPU there. So if I click on memory there, I open a second. I expand the report to see all the queries that are contributing to that weight category. Now here you only see one because, again, this is an artificial workload. I was running just one test. But you would see here all the queries that are contributing to that weight category, which is memory. You will see here for that query the same kind of familiar UI. You would see here that whatever plans exist in the timeline, and you see underneath the actual plan that was captured. So a lot of insight that can be derived from Query Store. And from here, you can still do stuff like, for example, force a plan, because in this case, for example, Query Plan ID 1 has consistently less execution time than Plan ID 2. So let's say I wanted to administratively say, no, this query will always run with Plan ID 1 because over time, this yields better performance. So I could click on Plan ID 1, click on the button Force Plan, done, I can go away. And I have other tools here. For example, I could select both plans, and I have a button here to compare both plans and to see if I can actually find a smoking gun that was making the plan change all the time, as you can see here, throughout the same timeline. So there's a lot of insight you can gain by looking at these tools here. Okay, and now let's look at diagnostic enhancements done to the engine itself. Now, one of the things we've done in 2019 has to do with tackling this scenario that you see on the screen here. If you've ever faced a long-running query that was actually essentially blocked on waiting for statistics to be updated, let's say you are running a very complex query, and it's the first time it's being run after you loaded or deleted a lot of data from the underlying tables. So that means that the statistics are outdated as it relates to the previous scenario before you inserted or deleted a lot of data. So SQL Server, if auto-update statistics is on, and it should, it's the heavy recommendation here, then SQL Server will actually update statistics before it continues optimizing a query plan, so that it does so with the latest updated data, right? But if you have a very complex query with a lot of statistics being loaded, And those statistics are created on very large tables that can take some time. And you essentially see a blocking scenario there, but a blocking scenario that you had no insight into. So we've added this new weight type, which is called weight on 6 statistics refresh. This is in SQL Server 2019. We'll be looking if we can backport this weight type into other releases like 2017 at least. And you will be able to see those weights being accrued in the CSDMOS weight stats, which means that, for example, the query performance dashboard, the SQL Server performance dashboard, I'm sorry, would be able to surface this one in that historical weights chart that we have there. Now, we also see in CSDM exec request, if you see a request waiting on this sort of operation, you will see the command there showing like this. So let's say if you run a select of any sort and it gets blocked, in CSDM exec request, the command will show just select, right? Now, if actually that read query, that select statement is waiting on stats update, we add this suffix, statman. So you'll be able to clearly identify if you are running into this scenario. This is not available in show plan weights because this is a pre-execution weight, so something that is accrued before execution of the query starts. And show plan, so an execution plan will store weights during execution. So it's a different scope, and therefore I just wanted to put that out there in case you wonder when you look at a plan why we don't have the weights there. Okay, so I just mentioned query execution plans. What do we have there? So you need to think about query execution plans as a map to how query execution was done. So you have information there on how data was accessed, how data was joined, the order of the operations, if you use parallelism or not, what are the actual row counts, and you can compare those with the estimations because the plan is calculated and based on estimations, which may differ sometimes quite a lot from the actual rows that flow through the plan. That essentially leads me to a scenario where I have an inefficient query plan. And it has a number of other information that is really useful for you to troubleshoot query performance. The last year and a half, and I actually have that as a personal passion, is to make sure that if you run into a query performance issue, and if you request someone to send you the actual plan so that you can take a look and try to understand what went wrong with that query execution, you shouldn't have to go back and ask for the same person to retrieve missing data. Oh, you need to go to CSDM exec weight stats and grab me weights from there. And oh, by the way, please go into CSDMOS latches and grab me the latch rate types from there. Or go into I mean, we don't want to make a painful process, which is query performance troubleshooting, even more painful because we constantly need to go back and request more data to kind of put together the ecosystem that the query was running on, the context, and then be able to more efficiently troubleshoot it. What we want is for all that relevant information for query performance troubleshooting to be right then and there inside the query plan if someone sends it to you. So minimum to zero going back for more information and doing everything from query plan. So with that in mind, here's something that we've been doing. For example, if you look at a query plan in SMS, you only had, actually you don't see it here, but you only had, you look at an execution plan, you look at an operator, you see something called cost and the percentage there, and that's it. If you wanted to know more about the metrics on that operator, you would have to right-click on the operator, click on properties, and it would show a side pane with a number of useful information. However, if you're just opening a plan, you want to immediately and visually pinpoint the heaviest node so that you can focus your efforts on analyzing that part first. So what we've done is in SMS V18 is, as you can see here inside the yellow boxes, just for highlight, you see inline the time it took to execute that particular operation and the amount of actual rows out of how many estimated rows were tackled by that operation. So for example, I see here that this clustered index scan, this non-clustered index scan, sorry, actually read 19,000 rows out of 19,000 estimated. So 100% coverage. This means that the estimations are accurate, and therefore we have fairly good confidence that this is the right operation, an index scan, to retrieve that data. However, further up the tree, sorry, we have a couple of other operators, these hash matches, that drove less rows than it was previously estimated. Now, this is not a huge difference, but if it were in the order of thousands of tens of thousands, then I would be very much concerned, and I would need to look at are statistics updated, for example, or do I need to tune this query in some other way? So it really brings out immediately in a visual fashion what are the heaviest parts of my plan. Obviously, we still have the thickness of the rows, which is another measure of how many rows are flowing through the operators. But I believe that this was a popular request in our user community, and we've done it in the latest SMS V18. So I invite you to go and download the latest version. You can point this to any previous version of SQL Server, and you will see the query plan as you see it here. Because this data was already being collected, it was just not being exposed in this fashion. Now, other information we've added is has to do with trace flags. Now, I just mentioned that to troubleshoot query performance, it's very important to understand the context in which that query is executed. And a very important part of that context is to understand if there were trace flags active in the system that could effectively change or greatly influence the way the query optimizer does its job. So it's very important to have that information in line when I'm analyzing a plan. So all this information I'm going to show in the next few slides is in the root node of the plan, meaning that if you look at a plan, if you right-click on the select node and you choose properties, it will open the window that has all these informations that I'm now talking about. So regarding trace flags, you see two categories here, 1 and 2. And what is this? So 1 is what are the trace flags that were present at compile time? And we see that these 3 trace flags were active in the system when this query was compiled and executed. And I can see 2371, 7412, and 9481. Now, from all these trace flags, the second part tells me which ones did not, I repeat, did not influence the query optimization. So by process of elimination, I see that 9481 actually was a trace flag active in the system that can influence query optimization. And what is this trace flag? In this case, this trace flag is forcing the CE70, so the commonly known legacy CE version. So it's important for me as I'm analyzing this query, if I'm looking at something that is an external influence to the query performance of the plan that I'm looking at. Other things have to do, for example, with parameter data types. We've made it easier to detect conversion issues when you don't have access to the source code. Now you may ask, oh, hang on, but if I'm looking at a plan from a store procedure or a function, I have the code right there, so I know the data type for the parameters. True. However, if you have something like this, which is, I'm seeing more and more application models using SP prepare, sending an ad hoc query into the engine, taking back a handle, a token, and then later going in and executing that previously prepared query over a specific database. If you are tracing these operations, or if you are grabbing a plan for this operation that was the actual execution, this is what you see. You don't see the plan for this query here. So understanding the parameter data type for the actual underlying query is super important, especially if I have conversion warnings that are affecting the ability of the optimizer to do its job properly. Now, other aspects have to do with statistics. So statistics are the building blocks for the query optimizer. It's how the optimizer has a grasp of the underlying data in all the tables that a specific query is accessing, and therefore understanding the status and which statistics were loaded by the optimizer to optimize this specific query is super important. So for example here, I can actually drive actions from looking at this data. In this case, I was looking at a query that was not very efficient, and I had changed the number of, I had changed a lot of the underlying data distribution in this table, and the modification counter was at this point at 19,000. Well, this table actually has something like 1,000 rows or 2,000 rows, something like that. So this means that because I know how many rows the underlying table has, and I need to have access to the system for that, I know that this number means that the data was changed a number of times, and SQL Server at this point is operating maybe under false assumptions, maybe under the assumption that the data is distributed in one way and it can be different. So what I can do immediately, if I'm seeing inefficient plans, looking at this is, oh, let me actually update statistics to see if this helps. And I can see when the plan was recompiled, modification counter went down to 0. I see other useful information like when the statistic was last updated. I can see the statistic name, the table, so a lot of useful information to understand which statistics were in use. And therefore, if I have a parameter sniffing or something like that, I can know exactly where to look for in the underlying schema. This was not available before, so you would have to scratch your head and go around sometimes some convoluted methods to try to map this information through running a trace or something like that. Now, something else we've done, by the way, Amit, please keep me in check. How long do I have here? If you can let me know. So, as I was saying here, persisting information on elapsed time and overall CPU time becomes very important on the overall query. If someone sent you the actual execution plan, then that means that you had a number of data before, but you didn't have the information about actually how much time the query took to execute and how much CPU time it took also. Now, that means that you probably have to go back to the person that sent you the plan and say, hey, by the way, can you please capture set statistics time on, or just kind of look at SSMS and look at the elapsed time counter that shows up in the bottom of the screen, and just let me know how long this query ran. That's really not something that we need to look for. So this is now in the plan itself. You can know exactly what happened. And in this case, for example, I see that the query took a minute and a half. And the majority of that time was actually active CPU time. So I may be looking at a query that is CPU bound. Now, if I keep in mind that this query was run as part of that system that I looked in the query performance dashboard and saw that was CPU bound on the overall system, then I'm starting to build hypotheses. Maybe if I can fix this query, maybe if I can make this query return my result set by using less CPU time, I can help my overall performance by decreasing overall CPU usage. So all of these tools and bits of information do connect to each other and allow you to build hypotheses that you can go more quickly test and drill down into. If you ever executed scalar UDFs, that's a very useful artifact for developers, because you can write sometimes complex pieces of code, stick it into a function, and then once you need to execute something in line from that function, you just call the function and that's it. So it can be a seamlessly simple way of reusing a complex code. However, an issue arises in SQL Server specifically, because if we're using a scalar UDF, let's say I'm selecting from MSTVF, multi-statement table value function, or I have actually a scalar user-defined function inline in my select that does a lot of complex operations. I don't see that complexity exposed in the actual execution plan of the query that I'm analyzing. I only see a single operator saying function execution or something like that. So it's very it's very, it's hidden, if you will, from whoever is analyzing the query. So we've added this information inline for you to see how much time, if you are using user-defined functions, how much time out of your overall execution time is driven by UDFs. We have done also work to optimize UDF usage in SQL Server 2019, and it's something that Joe is going to discuss in this session. Now, we mentioned weights. Weights are super important, so we've added the notion of how many weights, which weights the query was suffering from, if you will, during its execution. And at most, I have the top 10 weights, no more. I can see here, for example, all the weights that I had in a specific query execution, and they are in descending order. So I can see here that I had a lot of CX packet waits, and the overall wait time was 30 seconds. So during the overall execution, I waited 30 seconds for CX packet, and I can now correlate that with the overall query times. This is the actual elapsed time for this query. So I have 3 seconds of execution time, but I have 30 seconds of CX packet wait. This immediately tells me that I'm probably running this query. I'm obviously running in parallel, but I should be running this over a lot of CPUs in order to be able to turn this elapsed time into this wait time. And lo and behold, I can go I'm still in show plan. I'm still in the query execution plan, and I can actually see the degree of parallelism in which this query was executed. So maybe what I need to do here, because this query waited so long for CX packet, and I have this elapsed time, but you see that the elapsed time is 3 times the CPU time. That means that this difference has most probably to do with weights. And I do see the weights here, and I'm able to see that this was a high DOP. So maybe by decreasing DOP to a smaller number, I decrease this amount of weights, and therefore I decrease the elapsed time. So again, I didn't leave the scope of the plan that someone sent to me, but I was able to put together this scenario and an action, which is to decrease degree of parallelism in this example, just by looking at an actual execution plan without requesting further information. So by the way, the parallelism weights are only available in the versions that you see there. In previous builds of 17 and 2016, we don't have specifically the parallelism weights available in show plan. Okay, and continuing on context. So memory is super important for SQL Server execution. So understanding if I'm using memory correctly, meaning whatever memory I'm grabbing, I'm effectively using it, is super important. Because if I'm misusing memory, either grabbing a lot and not using enough, or not grabbing enough, that leads me to performance problems of 2 different sorts. In this case here, you see that a query was granted almost 800 megs of memory when it started executing. So it grabbed that memory. It will not let it go until execution finishes. But in the end, it didn't even use 1 byte. Now, if the max used memory is nowhere near the granted memory, that tells me that this was a very inefficient use of memory. Now, this is a value that is estimated. Sorry, it's derived from estimations. So maybe what I need to go do is update statistics and see if this changes, because if SQL Server is operating with the latest and updated statistics, that has a lot of influence over estimations that may lead then up the decision tree to different outcomes, and in this case of memory estimations. So I also have a number of warnings in case of these situations I'm going to show in a few slides. So what is happening here for all intents and purposes? If I have a lot of queries running with this scenario, think of these queries running in a server that has 10 gigs of memory, just to make it a very simple number. If every query is grabbing almost 800 megs and then not using a fraction of that, that means that I can run concurrently at most 10 queries, maybe 11 queries. And I may even have like 48 CPUs in this machine. That's irrelevant because I'm bound by memory. I cannot have more than X amount of queries running at the same time because they all grab almost 800 megs. And if I only have 10 gigs, then that's a simple math. And that's a problem right there. So having this kind of scenarios really hurts the ability of SQL Server to do concurrent workload. Now, we do have the other scenario that we're going to look at, which is if I didn't grab enough, then what happens is SQL Server will spill to TempDB. Spilling to TempDB means I/O, which means slowing down the query from that perspective. So we do want to be in the general vicinity of max use memory being very close to granted memory, because that is a measure of effectiveness of my query plans. Now, I mentioned warnings, and that's super important here. So I'm going to speed up a little bit because I think we're getting short on time. I still don't. Okay, I have another 15 minutes. Okay. Well.
Yes, Pedro, we have 15 more minutes. Yes.
If you guys can bear with me for actually another 20 instead of 15, I would really appreciate that. But it's really up to you. I mean, let me know.
Yes, yes, we can go. Yes, yes, fine.
Awesome, awesome.
Yes.
Because I really want to show you in the end a demo that brings all of this together. Okay, so as we're looking at here, so we have a number of warnings that are super useful to keep in mind. For example, this one that you see here has been around since SQL 2012, and if you see this is a dead giveaway that your SQL Server is memory bound, and here's why. If a query had this query actually ran in 42 seconds, that's the elapsed time of this query, but it had to wait for 40 seconds to grab memory before it started to execute. So in essence, this query is actually not so bad. It runs in 2 seconds. But the additional 40 seconds have to do with resource waits. So have to do with an overall, let's say, server issue that I don't have enough memory to run my workload. That may be because I have the scenario that I showed in the previous slide, which is a lot of queries are grabbing too much memory and then hurting the ability of others to start executing. And that accrues resource semaphore waits. So being very attentive to query plans really shows you a lot of information that you can use to troubleshoot an overall system. Still on memory, we have other warnings. That kind of scenario that we saw a couple of slides ago, that's actually translated into a new warning that we've added to SQL Server. So if we detect that we have grabbed excessive memory, meaning when the max memory that was used is too small as compared to the grant memory, then we surface this warning. And you can see in this case, for example, that the query grabbed 67 megs of memory to execute, but in the end, it used 1 meg. So again, think of a system that's highly busy, and it's supposed to be highly concurrent, but you have a lot of these queries that are misusing memory. You are actually effectively hurting the ability of SQL Server to do concurrent workload. Now, you can fix even these administratively. Let's say the first thing would be update statistics, and if this doesn't change, I even have a couple of hints that allow me to, let's say, do a hard limit on this grant. For example, I have the max % grant hint that I could use in this query or in Resource Governor to try to administratively fix this sort of issue. But it is, in essence, an inefficiency of the engine, of the optimizer, that stems from inefficient estimations. So therefore, goes back to statistics. And we have other conditions like the grant increase and use more than granted. I'm not going to dwell on those for the sake of time, but we do, suffice to say that memory is super important. It's very relevant that SQL Server runs its workload in memory as much as possible rather than resorting to disk. And therefore, knowing that if you are facing memory bottlenecks, memory constraints, is important, and that's why we surface all these warnings in Showplan. Now, spills is the reverse effect of instead of misusing memory, overusing memory. So if I actually estimate that I'll need, let's say, 5 megs to run a specific query, and then that memory is up, and because I misestimated the amount of memory I would require and I need more, I need to spill to disk, to work tables or work files to carry on execution. In this case, and starting with SQL Server 2014 actually, we added a lot of additional information to both sort warnings and hash warnings. And before you could only see the first sentence here, before the comma. you would see, let's say if you got in any previous version, if you got a spill on a sort, you would see that, oh, operator used MDB to spill with spill level 1. Well, thank you very much. Spill level 1 is not very self-explanatory. It's documented, but it's not very explanatory. So what we've added is all this other information. Sort wrote 4,000 pages to TMDB. So hang on, 4,400 pages is a lot of I/O. So maybe I do want to look at this spill, and I do want to look at improving estimation so that I can actually increase the amount of memory that this query grabs to begin with, so I don't incur in a spill. Now, in more recent versions of SQL Server, namely in 2017, for batch mode, we introduced memory grant feedback, meaning that if you had this once, in the second or third execution of the same query, we would gradually and automatically adjust memory so that you wouldn't get into these spills. In 2019, actually, Joe's going to show you that. We've even extended that not only to using column stores, which were tightly coupled to batch mode execution, but because we've made batch mode execution available to row store, that means that every query that runs in the system can leverage that feature. However, if you're running in SQL 2012, if you're running in SQL 2014, even in 2016, you don't have that. So you have other methods to try to increase memory. For example, you have the min grant percent hint that can administratively force a higher grant on a specific plan, and therefore you do away with this error. But like I said, this is important enough for me to tackle because it wrote 4,400 pages to MTB. But look at this one, for example. Because I do have all that additional information, I'm able to make a judgment call. In this plan, yes, I had a spill, but the spill only wrote 32 pages to MTB. That's not a lot. Now, if this query is executing every once and again, and I may have bigger fish to fry in this workload than try to do away with this spill, because it only writes 32 pages. That's very small. However, this one, the sort warning with 4,400 pages, that's relevant. So I may want to look after this one. Now, obviously, going back to the hash match, 32 pages is small if I run this query every once in a while. If I run this query several times a minute, and several dozen times a minute, then that becomes a cumulative effect that's important, and I still want to tackle this. But I'm able to come up with all these actions and hypotheses because I have this information now in show plan, and I didn't before. So what was cryptic now can actually be used. Okay, and that leads us to faster insights. So I'm thinking that unfortunately many of you in the call today have had to support tier 1 mission critical SQL servers. And at any point in time, you may have had middle of the night calls that wake you up and say, hey, everything's gone out of whack. There's this key business process that's taking a long time, or the server is down, sort of situation, and you need to go, and you're the hero that needs to go in and tackle the situation. I can't see a show of hands here, but I would assume that many of you have dealt with this. So this is for you. In this hypothesis, I'm getting a call because there's this key ETL that's being delayed, and I'm getting a call to say, hey, come on, this ETL is taking too long. It usually runs faster. There's something going on. You need to determine the root cause and mitigate the issue so that we can actually finish the ETL faster. Okay, so first you need to do is you fire up your laptop and you kind of scratch your head because you're just waking up, and you need to define the problem. Now, the reason hypothesis here is, okay, I had an ETL that usually runs fast and now it's running slow. That should be a long-running query. Maybe there's some blocking around, or there's some other issue at play, but I do have a query that's running for a long time. Now, to be able to use an actual execution plan, query completion is a prerequisite. I can't look at an actual plan if the plan is not completed yet. Now, that puts me in a conundrum. I've just seen all this useful information that inside show plan that can lead me to faster troubleshooting, but now I need to get the query to be completed to get all that information? Typically, yes. But we've also tackled that problem. So the actual execution plan isn't suitable for troubleshooting these long-running queries or queries that run indefinitely and never finish execution because, well, we never get the actual plan. I was working with a colleague, I think a couple of years ago, a little more than that, where they were running a query for 30 hours when they called me. Hey, Pedro, we have this query here that looks simple enough, but it's been running for 30 hours, and it's not business critical, but we kind of need to understand what's going on because this query should be fast. And I look at the query, and looks very simple. It's a simple select. Well, it's a select star, so first of all, big no-no. And then it has it's the from clause just joins what seems to be a couple of tables. Well, those were not couple tables. Those were actually a couple of views, very, very complex views. So immediately we saw this explosion of in the plan, or we would if we were able to see the plan. But this was SQL Server 2012, which didn't allow me to look at the actual plan, so we kind of needed to go a different route. I wish, however, I had this. The ability to do live query troubleshooting, the ability to look at the ongoing execution plan and look at it as it is executing to see if I can determine which area of the plan may be hurting the most without actually finishing the execution. In a case like my friend that was running the query for 30 hours, they had no end in sight. But if I had this, I could see something that is very close to the actual plan with a lot of the information we mentioned so far and be able to troubleshoot it just by looking at this. So how can I access a live query plan? Couple things. I can use, for example, you see here a screenshot of Activity Monitor. Now, over the years, I confess that I didn't use Activity Monitor that much. But when we started adding these features in, the ability to look at any session and see what that session is running live with a live execution plan, that actually gained a new value for me. So as you can see in the screenshot here, the show live execution plan is grayed out. And that's because to have in-flight query execution, to have visibility over that in-flight query execution, we need to enable something that's a mouthful. It's called the Query Execution Statistics Profile Infrastructure. Now, in essence, that has a lot of overhead, and it would make a bad thing even worse, because if I'm already running in a CPU-bound system, by enabling this infrastructure for the purpose of looking at live plans, I would add so much overhead, I can actually tip over and make the SQL Server just be almost unresponsive. So we've also understood that. So we understand the value of looking at a live plan, but we understand that what we had was too heavyweight. So what we did, starting in SQL 2016 SP1 and 2017, is that we added a new lightweight version of this profiling infrastructure. And that can be enabled globally by trace flag 7412. For the most attentive of you, when we looked at the trace flags that were enabled in my plan earlier, 7412 was enabled in the system. And we have a number of customers that are now using trace flag 7412 as a default in every SQL Server they run. Why? Because of the potential that at a moment's notice, if you need to do live query troubleshooting, it becomes available everywhere in a much lightweighter fashion. So the previous or the standard query profile infrastructure has a 75% overhead. This new lightweight, as we measured in a TPCC-like workload, has 1.5 to 2% overhead. So unless you're already running in a system that is like 95% CPU all the time, if you enable this, and you can live with that 1.5% of added CPU time, and unlock the ability of do live performance troubleshooting, this is invaluable for DBAs and developers. Now, there are other ways of enabling this instead of being overall for the system. You can do that for a specific query by using this hint, for example, and that's only after certain versions. But it doesn't allow you to do this, which is to go to Activity Monitor and right-click any process and do the live execution plan. However, if I enable 7412, I'm able to do, and by the way, yes, but this is now the default in SQL Server 2019, and there's no trace flag needed. So whatever I'm discussing up until now becomes a default in SQL Server 2019. And that's because we have so many customers running this all the time, and it's proven to be so useful in any number of query performance issues that we just made the call that this is going on by default. Now, this is what enables you. I can now go into Activity Monitor, for example, right-click on any given process, and there you have it, Show Live Execution Plan. And immediately another window opens up, and I see the plan ongoing. Now, there's a number of things here that you can that we've enabled also. We have another DMF. If you don't want to use this tool, you can actually access this dynamic management function and get the snapshot of the live execution plan as it's ongoing at that precise moment that you call this DMF. Now, keep in mind that there are other, let's say, artifacts that still use the regular overhead profiling infrastructure, but all these other features use the new lightweight profiling infrastructure. Okay, so this is the demo that I have here. Just before I go there, I want to show you the overhead that we measured. So as you can see, 1.5 to 2% on SQL Server 2016 SP1 and above. So compare that to running the regular profiler. This is why customers in very large estates are running trace flag 7412 on by default in every single server because of the potential it gives you. And what is that potential? Let me show you that in a demo here. So let me start here let me go and connect here. Okay. I'm connected to my server, so bear with me for a second. Okay. It's coming up. Come on. You can do it. It seems I'm being plagued by this is loading. Let me also show you something else. We have this Tiger toolbox. It's a fairly easy short URL. And here we not only share a number of tools and scripts and whatnot, we are also sharing a number of demos that we have. So if you come here to sessions, for example, this, as I said, it's a repeat of a session I did at SQL Intersection last week. And this live query troubleshooting demo that I was supposed to show now, it's here. Okay, it's come up. So it's zipped here. It has all the instructions. You can run that for yourselves. Okay, let me close all this. Actually, put another one. Okay, good. Okay. So I have my, oh, come on. I have my SQL Server here. I'm gonna bring in the demo that I was running. I should be running. Give me a second here. Okay, good. Come up here. Oops, it's the other one. Here. Yep. Okay, and let me run this scenario here. Let me just check that this is where. Yes, it is. Okay, good. So I'm that DBA that got the middle of the night call, right? And I'm firing up my laptop, and the next thing I do is I need to connect my trusted SSMS. And inside SSMS, let me just go back here. I just want to make sure that I'm in the right. Okay, of course, this is the wrong. There we go. This fixes it. Okay. So I'm running this this heavy ETL. It's taking a longer time. I'm being asked to do something about it, right? So I can fire up my trusted SSMS. It's still setting up the scenario, so give it a minute. By the way, you will need to run this. You will need AdventureWorks 2016. and then the script will take care of itself. It will run some setup first because it needs to populate some tables, and then it will start running that workload. Okay, so I fire up my SSMS, and I right-click on the instance, and one thing I have available is the reports. And inside the reports, standard reports, I now have the performance dashboard, right? So I can take a look at that. That could be one entry point, and it will show me the current performance status of this server. Now, being a report, that means that this is a snapshot, and therefore you may need to refresh it to get an updated view. And this is retrieving data actually from a number of underlying DMVs and DMFs to build the rich visuals that you're going to look at. So while that is loading, I'm also going to look at Activity Monitor and let it load in the background for a minute. And it's probably not a good idea that I'm looking at all these tools in the same server that I'm running workload. So I can see the performance dashboard here live, and I can click here, I can look at a number of details over the weights that I was seeing and whatnot. In this case, this was not giving me a lot because the server was not using a lot of CPU, as you probably noticed. So not a lot I can read from. Not a lot is being affected by the weights overall in the system or the overall system status. Now, I can go into processes, however, or even in active expensive queries, which is quite useful, and just give it a moment for it to start populating. This is the thing that I actually would point out to Activity Monitor. It may take a few seconds to start populating, but once it does, then there's all these tons of useful information around here. Okay, so it's coming up. I have 74% CPU time. I have 9 waiting tasks. So I have blocking obviously occurring in the system. And this should give me some information in a minute now on actually what is happening in the underlying system. Just waiting for this to populate here. Come on. Oh, and another thing I wanted to show you about the demo while this is loading. What? Don't print. What am I doing? Okay, I just printed something I shouldn't somewhere. Not only do you need to change your SQL Server here, but also keep in mind that this is setting the number of threads in which this workload is running. So this is taking the overall number of processors you have in the instance and then dividing by 4. If you want to actually not run any background workload, for example, which I was running, and this is actually affecting the performance of my demo, you can just remove them. Yes, let's do that. Let's end and restart. Okay, shutting down. There we go. I'll start again. Okay. Am I on the right one? Yes. Any questions so far, by the way, while this is loading? Amit, I can't see any chat windows, so if you'd be so kind to let me know.
No questions so far.
Okay.
If at all people have questions, they can put up their questions in Q&A panel.
Okay, sounds good. Okay, so we do have processes now loading. Good. And you see that you have a number of expensive queries here. Look at the elapsed time. It's already like over 10 seconds. And as this gets refreshed, you'll see that this time will look at this. This is actually a few of them are already over a minute now. So, okay, I think I found the long-running queries. But what I can do now is right-click on a query, any session that's running this. So I see this running in any number of sessions. So my ETL is ongoing. It's running this query. I have previous knowledge that this is the query that my ETL runs. And I can look at the live execution plan. As I see this, hopefully you're seeing this on the screen as well, I see a live execution plan that I can traverse. And so it's a rather complex plan, as I can see here. And I can start moving. I need to start moving all the way to the right because plans are shown from right to left and bottom up. So I can see that I'm building here. Let me try to bump this up. I'm building here a table spool, and I'm building here another table spool, which is usually a big no-no, although a spool is present to the optimizer puts a spool here to overcome a underlying inefficiency that we may have in terms of indexes and whatnot. So my point being that, look at these numbers. This spool is estimating that it will get 165 billion rows, and right now it's on less than 1 million, so it will take some time, right? So this is slow, but look at this as I go up the tree. I start, because I now have this information readily available. I go up the tree and I see estimations getting worse and worse and worse. I get to this point here. On this nested loop coming out of that very heavy branch, look at this. I've counted the zeros, by the way. I have 23 quintillion rows estimated. So this will take a while. Well, actually not, because I don't have even these amount of rows in the table, in any table, or all the tables put together. So I obviously may have here some misestimations and inefficiency in the plan. Now, let me take a look at the query and look at it. Maybe there's something in the query that calls out. So I have here the query text, which this is not very readable. So I can click on this button here and actually look at the query text. And OK, this is a rather complex query. It has a lot of joins actually with functions in the predicates, in the join predicates. So not a very bright time for my developer that built this, but still OK. What else can I get? Now, we looked at a number of properties today, right? So let me look at the properties of this plan. Right-click, Properties, and let's see what I have here. Let me bump this up. And I have here information about, OK, the actual number of rows so far. This is interesting, Cardinality Estimation Model. This is showing me 70. We now know 70 is the Cardinality Estimation Model that started in SQL 7 and went all the way to SQL 2012. But I'm running this in SQL Server 2017. So right here, I have something that catches my eye. Now, let's continue, and I see the estimated number of rows, the estimated cost. This is very, very big. Looking at memory grant info, I see that I'm not potentially requiring a lot of memory, so I may actually end up spilling somewhere. As I continue on, I see I want to try to better understand the context in which this query is running. So let me expand the trace flags. And I do have trace flags here running. And I do have those two categories here, right? So I see 7412 is enabled. OK, 7412, I know it enables lightweight profiling. That's actually, look at all this running. So that's good. And I also have 9481. Oh, OK. 9481 it's a documented trace flag. And it's actually forcing old CE at the system level. And I know it's old CE because I can see it right here in the execution plan. OK. So it's 3 in the morning. I'm not feeling very imaginative to go and tune this query right now. So is that something quick and dirty that I can try to see if this improves? This query is still going. So it's going for minutes now. And if I go back to my activity monitor, I see that, I mean, it's just going and going and going. OK. Is there something I can do to try to fix this? For example, can I try to use some hint to make sure that the query runs differently? For example, I'm using the old CE. What if I use the new CE? Does it help me? Let's check that out. I can use this hint just as a test to force a default cardinality estimation. What does it mean, default? Default for the dbcompat level on which my database is running. I know that my AdventureWorks 2016 database is running under the dbcompat 140, which is the highest available. So I'm going to force that cardinality estimation model rather than the legacy C that I have. Let me grab the actual plan. Let's run this and see how long it takes. So the other query is still ongoing, by the way. It's still here. It's still being built very, very slowly. You see the numbers slowly moving here. So it's very resource intensive. What about this query is done. Actually, it took what, 5 seconds? I can look at the properties, see query time stats here, and it actually took 1.3 seconds to execute. So I can go back to my developer and say, hey, I don't know why you were using old CE, but this query I just tested, it runs fine with new CE. Just use this because we have the trace flag running in the entire system. Put this hint in the code, run it again. Instead of waiting hours, we'll actually be running in seconds, and I'm going to bed. And there you have it, because with live query troubleshooting, I was able to determine what was going wrong by looking at the actual executions. I was able to look at the query plan and see information there that drove me to formulating an hypothesis. I experimented on that hypothesis here because it's just a select, so I could just as well run it in production. That's fine. I'm not changing anything. And I was able to come up with essentially a mitigation that I can go back to whoever is requesting me to troubleshoot and deliver that mitigation. And with that, I just did what I could do this in a few minutes and go back to sound asleep. And guys, this is what I had today. I wanted to leave you with this. We also fixed the infamous truncation error in SQL Server 2019, but we also backported to CU12 in 2017. So if you ever ran into these types of issues when you're running large ETLs, and then you suddenly get single byte narrative will be truncated, you don't know where it's coming from, now you do. So hopefully this is useful for you. And I'll just leave you with, it will be on by default in SQL in 2019. And I'll leave you with these bookmarks, some short URLs for very important but somewhat obscure parts of the documentation and other resources that you may find useful. Again, my apologies for being so late today. Hopefully this was useful for you, and I'll see you next time. Amit.
Thank you very much, Pedro. It was wonderful, even though we ran a bit late, but it was worth everyone's time. And friends, you guys can start posting questions in the Q&A panel. And while you post questions, I'll just quickly take you through a few slides, and then we will be throwing your questions at Pedro, and Pedro will be answering them. So friends, please use the Q&A panel. And so Pedro, I will take the control over from you now.
Yes, do that. Sure.
Right there. So friends, just want to quickly run through these slides, and I know it's late, won't take much of your time. This was all part of our community efforts under Data Platform Geeks. So there are many things that we do under eDominer, but today's focus was Data Platform Geeks. Formerly it was known as SQL Server Geeks. And apart from free webinars and events that we keep doing from time to time, we have a signature event which is touted as Asia's largest data platform conference that happens in Bangalore in the month of August each year. And very recently, in this month of August, we executed Data Platform Summit 2018. It was organized in Radisson Blu Hotel in Bangalore. And as someone says, picture speaks 1,000 words. If you look at this, this was a massive gathering of people like yourselves from more than 15 countries that came over and learned from Microsoft Redmond experts, global MVPs, and MCM. So it was fantastic. And on the back on the stage, you can also see the Microsoft Corporate Vice President, Rohan Kumar, is too far there, and all of us out there. And the URL for you is dps10.com. And in dps10.com, if you go now, you will see that we have already announced the dates for next year's conference. August 22, 23, 24 is the conference. And this time, for the first time ever, we are going to have 3 days of pre-conference, 19, 20, and 21. And we're just going to get better and bigger over the last year. So those are the contact details at the bottom for you, dps10.com, and the phone numbers. My colleague Satya or Rohit will be putting down some links in the chat window for you to see. People do ask, why should you care about this conference? Well, just 2 important things: professional education and networking. We get some of the world's best experts to train you at this conference, and you just had a wonderful session from Pedro. And let me tell you, Microsoft Redmond experts, when they fly down to Bangalore and deliver sessions, it is priceless. It is incredible for a community like us to learn from them. So reskilling and upskilling is one of our major focus. You get to network with your peers and Microsoft experts and global MVPs, and you make connections for life. We invest quite a bit in providing some world-class infrastructure at this conference. Session choices, pre-con choices, we put up all of this for voting. So you as community can actually vote which session you want to see or which pre-con you want to see. And based on your feedback, we choose sessions. And to let you know, you can go ahead and pre-register for Data Platform Summit 2019 today. And it does not cost anything at all. You don't have to pay anything. Pre-registration means that you will basically get a pre-launch discount code in January, which will give you the lowest pricing for the conference. And of course, who doesn't really want to get inside the conference with the cheapest price? So that's just quickly about Data Platform Summit. So just go ahead, evaluate the conference, evaluate what we have been doing in last 4 years. dps10.com is the URL. Thanks to our core team. My name is Amit Bansal, as I said before, and we have a big team here: Manohar, Avanish, Vijay, two Vijays, in fact, from Hyderabad, then Manohar from Australia, Sandeep, Prince, Surbhi, Sakaram from Bombay, Devnath from Calcutta. And this is the team that actually helps us with many of our community events. So kudos to them. They're all part of different, they work for different companies, and they give their voluntary time. But what we are doing today, these webinars and events and even the conference, not even a second of this is possible without the eDominer teams across Bangalore and Calcutta. And today it's like closing on at 11 p.m. India time. Our team is live trying to close this webinar and execute it. So thank you guys. This was our entire team at DBS 2018 conference, and I love sharing this picture with all of you. Special thanks to Microsoft. It's one company that has really come forward, supported the community efforts, and it's incredible to work with a company like Microsoft, and also very thankful to all Microsoft speakers and veterans who have supported us. Data Platform Geeks community, all of you are members. Continue remaining members. Now, the most important thing is you are a member of DataPlatformGeeks.com, so you don't need to register again and again. Whenever you want to register for the next event, rather book your seat for the next event, a webinar or an in-person event, just go to DataPlatformGeeks.com, log in with your credentials, and book your seat. We are also coming up with a new meetup model. If you see on the right-hand side, if you want to organize a meetup in your organization in Bombay, Bangalore, Chennai, Hyderabad, Gurgaon, Pune, Noida, wherever you are, just fill out the regional mentor form, which is on DataPlatformGeeks.com in About Us. So in About Us, if you fill out the form, we will revert back to you. Beyond this webinar, if you have questions, here are some important links. In the chat window, you will have the links. So the Facebook group, the LinkedIn group, and we are also on mobile using the Telegram app. So we just make it possible for you to ask us questions in all possible ways. Okay, most important question about recorded webinars. All our webinars are recorded, including this one. You can access them at youtube.com/SQL Server Geeks. So SQL Server Geeks used to be the former name of Data Platform Geeks. So our channel is still by that name. All of you should make a point to subscribe to that YouTube channel now. We also keep putting up a lot of performance tuning and internals video. That's on another channel, SQLMaestros, youtube.com/SQLMaestros. So just go ahead and subscribe to both the channels. There's a lot of free content out there. Friends, just 2 more minutes and I will hand over to Pedro. If you are looking out for some learning solutions around Microsoft Data Platform, SQL, Power BI, Artificial Intelligence, Machine Learning, there are a bunch of these masterclasses from SQLMaestros. I'm very thankful to our colleagues, our MVPs who have partnered with us to bring these classes for you online. And many of these experts are global experts, and they don't come to India quite often, and they come to only our conference in Bangalore. So we partnered with them to bring their content, their classes online for all of you. So leverage it. That's one, masterclasses. The other is I am putting up my performance tuning course in a video format. I mean, entire more than 100 hours of content. You can learn more about that on SQLMaestros.com. We also have hands-on labs, a very practical way of learning, a library of more than 120 hands-on labs. It's all up for you to grab out there. We're also developing learning kits. So if you're an instructor or a student and you want to learn via a learning kit, there are some options out there. And in case you need some SQL Server health check, just go to SQLMaestros.com. So these are this is the URL, SQLMaestros.com, where you can get access to all these learning solutions and health check. And that's our email ID, contact@SQLMaestros.com. Just write to us and someone from the team will revert back to you. With this, thank you very much, friends, for your time. One small request, Pedro, we should all thank him. He's got a pretty early to deliver this webinar. So kudos to you, Pedro. Thank you very much. We're very grateful that you came online and delivered this session. So we're going to put up a so-called webinar picture on LinkedIn and Facebook, and we'll send a mail to you. Do give your feedback and comments on that.
Sounds good.
Thank you very much, friends. So, friends, over to Satya. And Satya, you can take the Q&A forward, whatever time it takes, 5-10 minutes, and then we can close.
Yes, before that, just one more information. We have got 100+ people from 26 countries today.
Wow. So we had 106 people who joined from 21 countries. Pedro, this is amazing. Thank you.
26 countries today.
I feel even worse today than I had all these connectivity issues. My thanks for sticking around all this time.
No, it has been an incredible audience. None of them left, so they all stuck around. So yeah, it was wonderful, incredible. So let's start with the Q&A. And Pedro, you can also see the questions in the Q&A panel.
I've answered all the ones that are there already. So there were a number of questions around that I've addressed. There's one specifically I didn't quite understand, which is from Sashi Kumar Singh, and he was asking or commenting if we have a way to find out a performance dashboard like Oracle AWR report. I'm not familiar with what this report is. So if you want to ping me offline or something, I'd like to understand what you mean by this. But otherwise, I've been answering the questions that are on the Q&A window. Anything else?
So I think those are all the questions.
Okay.
All right.
Well, the demos are in the Tiger Toolbox as I showed. You'll make the webinar available. The deck is also available in our GitHub. So feel free to go through it. There are notes in there. And if you choose to, if you have any questions remaining, I'm one tweet away.
Perfect. So thank you, friends. Thank you very much. Thank you, Pedro. You have a great day ahead. More questions, friends, please use the links that we shared with you before, which is right here. And we will answer. We will continue talking to you and interacting with you. Thank you, everyone, for joining today. Thanks, Pedro.
Thanks, everyone. Bye.